Okay, students, lesson 5-7, triangles and coordinate proof. Some of you are going to love this, some of you are going to love to hate it. So it is a little bit different, but let's see if we can help you figure this out. There's a little more algebra and kind of problem solving involved here. So first thing that we have to do with triangles and coordinate proof is talk about positioning and labeling the triangles. So this is the part we'll start with. Coordinate proofs use figures in the coordinate plane and algebra to prove geometric concepts. The first step in a coordinate proof is placing the figure in the coordinate plane. So some key concepts or some key ideas of placing triangles on the coordinate plane, and really use this for any figures. One of them is use the origin, okay, usually as a vertex or the center of the triangle. So this uses as a vertex. Sometimes we use the origin as like to center it. So we use it kind of more in this way, but you want to use it kind of one or the other. The second hint is to place at least one side of the triangle on an axis. So use an axis. So you can see that down here. You can see that right in here. The third one is keep the triangle in the first quadrant. So first quadrant is nice just because it's all positives. You see that here. You don't see that here. And this is one of them that we kind of break some of the times, because in this case, we can keep it symmetrical about the axis, and that's kind of nice. And then lastly, use coordinates that make computations as simple as possible. So what we mean in this case is, if you notice here, they used a 2a for C, which allowed, when you found the middle point of B, which allowed you to use A instead of using, like if they used A for this point, then they would have to use 1/2 A for this point right here. So we're going to keep it as simple as possible. Now, these are only guidelines. You do not have to do them. You can break all of them if you want to. Most of you are not going to, because these do make this a lot easier. Okay, so placing figures. So here's an example. Position and label isosceles triangle. Lots of information here. Isosceles triangle, JKL, on the coordinate plane such that the base, JL, so we know that that's going to be the base, is 2a units long. The vertex K is on the y-axis, and the height of the triangle is b units. So lots of information here. Now, the one thing that I look at this and I'm like, okay, it's got to be, is that vertex K is on the y-axis. So I'm like, okay, I'm going to put K. And it doesn't matter how high or how low you put it, but I'm going to put K there. It also tells me that the height of the triangle is b units, and that my base JL is going to be, or it actually doesn't tell me, it has to be on the axis, but I'm going to do that. So I'm going to put my base JL down here. So this is an isosceles triangle with a base of JL, which meant that K had to be in the middle of the triangle. So if K was on the midline, I had to make J and L on either side like this. So lots of things now. The height of the triangle is b units. So I know that the distance from my O down here up to K up here is b units long. I know that JL is 2a units long. So if I think about this just kind of a little bit right now, is then I know that from O to L, this is a units, and from J to O, that's a units long, to list those. And I think that's everything I would have. So I'm just going to finish off my triangle. And when it says position and label, we've positioned the triangle now. We need to label. We also need to give ordered pair coordinates for each of these letters. So K, let's think about this. If I'm going to say, how did I get to K? You always go from 0, 0. And I went left to right 0. And I went up B units. So 0B is going to be my coordinates for K. For L, from 0, 0, I went right A units. And I went up or down 0 units. For J, I went left A units. Now be careful with this one, negative A, comma, up or down 0 units. So one thing we do when we're positioning figures is we assume the variables to be positive, and we put a negative in front of them if we want it to represent a negative number. Okay, so that's what you should get for that positioning and labeling. Things that could be different is you could have put in your K down in the negatives, which would be fine here. Your figure could also look a lot different. Like it could look like this. You would have the exact same coordinates for K though. Just your B would just be a lot smaller. Okay, so a study tip, if we flip the page there and we look at that study tip, you may want to place isosceles and equilateral triangles on the coordinate plane so the uppermost vertex lies on the y-axis, just like what we just did. Then you can use the properties of isosceles triangles to label the coordinates easier. So the isosceles triangles is always, if you know what the two sides that are congruent, this vertex angle is directly above the midpoint of that opposite side that's there. That's going to be something that's going to come up a decent amount, and that's what that's talking about. Okay, so name the coordinates. So sometimes we position it, sometimes it's positioned for us, but you need to be able to tell me what the coordinates are. So we are told this is an isosceles right triangle, and BC is A units long. So I know that BC is A units long. Now, here's the interesting part. Isosceles right triangle. So I know the right angle has to be here based on how it's kind of positioned in the figure. And if this is going to be an isosceles triangle, think about a right triangle. The hypotenuse has to be the longest side. The hypotenuse cannot be the same measure as either of the legs, which means for this to be isosceles and have two congruent sides, it has to be these two. So if I know that BC is A units long, then I know that AB is also A units long. So if I'm going to fill in my ordered pairs, this would be 0, 0. Over here, to go from 0, 0 to C, I went A units right and up or down 0 units. And to get to A, I went left or right 0 units, and I went up A units. So those are my ordered pair coordinates I would get. Okay, so then that leads us to being able to do coordinate proofs. So to prove geometric concepts, writing a coordinate proof, you are going to place the figure on the coordinate plane. So you need a drawing. Sometimes it's given to you. Label the coordinates of the vertices of the figure, and then use algebra to prove properties or theorems. So I'm going to add a little bit into that, and that is that you are going to use really three things. You're going to use distance formula, which is going to allow you to say that you have congruent sides. You can use distance formula to allow you to say that you have like midpoints of something, bisectors of something, but that's what it's going to allow you to do. So you're going to use a squared plus b squared equal to c squared a decent amount in this. You are going to use slope. It's a fun one. So your slope formula, y2 minus y1 over x2 minus x1, and you're going to use it where you've got to show the algebra. You're going to use algebra, so you have to show that algebra in order to prove it. But you're going to use this formula in order to show parallel lines. Think about parallel lines will lead to alternate interior angles, corresponding angles, things like that. You're going to use slope to show perpendicular lines, which will lead to right angles. That will help us as well, okay? And then you are going to use potentially the midpoint formula, which is, again, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Okay, the midpoint formula is going to allow you to say that you have a midpoint, which allows us to say that we have some congruence. So those are kind of the things that are going to pop up in the next little bit here. Maybe make a big note of that so that you have them. But that's kind of what's going to, what you're going to see. Okay, so here's a check, and it's a fill in the blank check to kind of go through it. I'm going to try to pick it apart a little bit more. So write a coordinate proof to show that ABX is congruent to CDX, and you're given this picture over here. So ABX and CDX is what we're trying to prove congruent. So the blank of AC is this or this. So we're looking at, in this case, midpoint. So the midpoint of AC, so they're trying to show you the midpoint of AC. And what we're going to do a lot of times, it's not going to be in a paragraph, is we're going to say in this case, midpoint of AC equals, and we're going to solve it. So the AC, if I'm going to find the midpoint, I'm going to add my X value. So I'm going to do 0 plus A plus X divided by 2, comma, and then I'm going to add my Y values, 0 plus B divided by 2. And that simplifies to, if I want to simplify it, that's where I get the a plus x divided by 2, kind of, comma, b divided by 2. So that's what they did in that first step there, and that's kind of how we're probably going to write it. Then they also found the midpoint of BD, and they did the midpoint of BD by doing the same thing. So we do 0 plus x, the x value of b, plus d was a, divided by 2, comma, and then the y value, so b plus 0 divided by 2, which is equal to, and I'm just going to choose the way I write this. So 0 plus x plus a, I'm going to write as a plus x divided by 2, comma, b plus 0 divided by 2 is b divided by 2. So that's what we get there, okay? Because x is located at that point, so this is x, okay? Then that means that x is the midpoint of AC and BD. Okay, and really it's by what you have up here, but it's by your midpoint formula that's allowing you to say that. So we've got to that step. By the definition of a segment bisector, we have some bisectors in here. Therefore, what this is going to allow us to say is that BX is congruent to XD. So we can say that BX is congruent to XD, and we can say that AX is congruent to XC. So we've got that congruence as well. So we have two sets of sides that are congruent. We have a set of sides here and a set of sides here, all based on what we did with those midpoints. Now, some of you will just do distance formula, and that's fine, but that's an idea there. Okay. From the, in this case, we're talking distance formula. You're able to get to this. So we get to, like, I need to know AB and I don't have it. There's other ways to do this, but this is how they're going about it. So actually, let's do it this way, is you can look at what they did here with the distance formula. They showed their steps with the different pieces and then simplified. And yes, you will show these steps even with doing a squared plus b squared equal to c squared. But if I wanted to, I'm going to take the shortcut route here. Based on looking at this and doing my coordinate proof, I've been able to say the sides are congruent. I can actually now state that angle BXA is congruent to angle, I got to find it right, DXC by, if vertical angles, then congruent. So I'm going to use my vertical angles in here because what I notice now is I have side angle side that proves my triangles are congruent. So because I now have my two sets of sides and my set of angles that are congruent, I can say that my triangle ABX is congruent to my triangle CDX by side angle side. Now again, they did it differently, so I'm just giving you a different method to end there, just to show you something different. I also gave you an idea of how it looks if it's not written in paragraph format. Okay, so then there's the check with the coordinate proof of the midpoint. So there's the given. And I believe this whole thing is here for us. So let's just talk through it. A coordinate proof to show that the three segments joining the midpoints of the sides of an isosceles triangle form another isosceles triangle. So the idea here is that if you are given this piece here and you take and join the midpoints of each of them, that you get an isosceles triangle in here. So we're given an isosceles triangle ABC, BC congruent to AC. That's the ones that they chose to make congruent. RS and T are midpoints of the respective sides. You're trying to prove that RST is isosceles. So what you need to do is you need to find the midpoint of those sides. So midpoint R, we know it's a midpoint. We do A plus 0 divided by 2, B plus 0 divided by 2. You get your midpoints, okay? So we have our midpoints of each of those. Then you're going to take and try to prove that RST is isosceles. So if you do the distance of RT and the distance of ST, if you can say that those are equal to each other, then you've got an isosceles triangle. So what they did is exactly that. So we have RT, so we have our R units and our T units, and we say that A over 2 minus A quantity squared plus B over 2 minus 0 quantity squared, which is equal to A over 2 squared plus B over 2 squared. And then we've got the square root of that. So we're going to leave it there. There's no reason to simplify anymore. We do the same thing with ST and we get to the same thing. Now, a little bit different here because we have 3A over 2 minus A, which we can write this as 2A over 2. A is the same thing as 2A over 2, and that's where they get A over 2. But we get to the same thing. So since we can show that these are equal, RT is equal to ST by those distance formulas, and therefore RT is congruent to ST by the definition of congruence, and triangle RST is isosceles by the definition of an isosceles triangle. So that's kind of the idea behind what we're doing here. Okay, so then you can get into, you know what, I'm going to leave that one alone. I think we've done enough with all of the different formulas. We're going to give you some time to try, and then you can ask me questions if you have them.